The next problem which we have is having an equilibrium between N2O4 which is getting dissociated into NO2. We are given with the fact that N2O4 is 25% dissociated at 37 degrees centigrade and 1 atmospheric pressure. We need to calculate the Kp for the reaction and we need to find the percentage dissociation of N2O4 at 0.1 atmospheric pressure and 37 degrees Celsius. To start with this problem, we first of all write the equilibrium reaction for the dissociation of N2O4 into NO2. Let us assume that we begin with 1 mole of N2O4. If the degree of dissociation of N2O4 is alpha, then at equilibrium N2O4 will have a concentration of 1 minus alpha and NO2, which was 0 earlier, will be equal to 2 alpha, and we know that Kp is equal to Kc into RT power delta N, where delta N is equal to stoichiometric coefficients of all the products minus stoichiometric coefficients of all the reactants. This can further be written as Kc into P upon sigma N part delta N by using the ideal gas equation of PV is equal to nRT and taking the volume to be equal to 1. And we can say Kc is equal to concentration of NO2 whole square upon the concentration of N2O4, which is equal to 2 alpha whole square, that is 4 alpha square upon 1 minus alpha. So this can be written as 4 alpha square upon 1 minus alpha into pressure, which is given to be equal to 1 atmosphere. So 1 upon total number of moles at equilibrium. At equilibrium, number of moles of N2O4 is 1 minus alpha, NO2 is 2 alpha. So total number of moles is 1 minus alpha plus 2 alpha, that is 1 plus alpha. And delta N is stoichiometric coefficient of products minus reactants. This is 2, this is 1. So delta N is 2 minus 1. So this becomes 4 alpha square upon 1 minus alpha square. This is the value of Kp at 1 atmospheric pressure for the reaction. And we know that alpha is given to be equal to 1 by 4 since the dissociation is 25% for N2O4. So we can find the value of Kp to be equal to 4 into 1 by 16 divided by 1 minus 1 by 16. This is equal to 4 upon 15. This is the answer for our first part. For our second part, we need to find the percentage dissociation at 0.1 atm and 37 degrees centigrade. Now our Kp is equal to 4 square upon 1 minus alpha square into the total pressure, and this is equal to 4 upon 15 because Kp for an equilibrium reaction does not change. So alpha square upon 1 minus alpha square into pressure, which is 0.1 atm in the second part, this is equal to 15. 1.5 alpha square is equal to 1 minus alpha square. So alpha square is equal to 1 upon 2.5, which gives the value of alpha to be equal to 0.65. That is the percentage dissociation of N2O4 into NO2 at 0.1 atmospheric pressure is equal to 65%. Hence the answer for our first part for the value of Kp is equal to 4 by 15, and for the second part the percentage dissociation of N2O4 into NO2 at 0.1 atmospheric pressure is 65%, and these are our final answers.